We are understanding now. We have seen the hydrologic cycle earlier. Now, with regard to the hydrograph, we need to understand two flows important, very important. One is the surface flow. This encircled value surface runoff. It is on the surface, you can say overland flow here taking place on the land and then joining this stream here. The second flow is the groundwater. So many rivers are being fed by the groundwater and it is joining. Suppose this is Narmada river. Narmada is perennial river. So from where the water comes when it is not running, the groundwater stored in the formation, earth formation, that keeps appearing in the valley, Narmada Valley or any river valley which is perennial. So this groundwater is contributing here. So there are two types of water which is causing flow in a given channel. One is the surface flow, second is the groundwater flow. So this groundwater flow is base flow. This is base flow. This is continuous and not fluctuating. This surface runoff occurs only when there is a rainfall event. When there is a rainfall event. So your hydrograph is consisting. Hydrograph, what is hydrograph? We draw a graph at a section, at a particular cross section of river. Suppose this is Narmada and this is Kevadia colony cross section where we are creating a dam. We want a hydrograph at Kevadia. So what we do, we measure the flow discharges versus time. Time means daily or hourly. Say morning 7, then 8, 9, 10, or on Monday, Tuesday, and all 365 days of year, and so on for 10 years. We measure the flow on Narmada at Kevadia site cross section there versus time. So all the ordinates represent discharge in the Narmada river at Kevadia. So that is a hydrograph. So let us see that how these two surface runoff and groundwater contribution to a channel flow, a river flow, here where we are measuring, for which we are drawing a hydrograph. We draw a hydrograph here where my cursor is. On your screen is a typical hydrograph sketch. Very interesting and need to understood properly that what it is and what are the different components. First, let's divide this graph into two parts. One is this gray here and second is having this orange solid line. It represents the hydrograph line. Below this is the shaded area, out of which one is the light yellow and the second is the dark yellow. This represents two types of water. One is the storm runoff and second, this one is the base flow. This is the base flow. Base flow is nothing but groundwater flow into the channel. This storm runoff is nothing but the runoff which we have seen earlier here as runoff this. So you could correlate these two flow here. This area above this dotted line represents that this amount of water was passing through the particular section of a river because of a rainfall event and storm event through that section. But this dark water here is always passing through there because of the groundwater contribution to the channel. This, I come back to this gray portion. This gray portion represents the heterograph, which we have been discussing throughout the chapter of rainfall, that it is intensity versus time. You draw that rainfall intensity versus time, heterograph. So this is the rainfall event. This gray area represents rainfall event which has caused surface runoff. This is event of rainfall which has taken place in the given watershed, And this rainfall event, this gray rainfall event caused this water discharge into channel, which is having peak here and then the recession and then again lowering the total value. Now, let us understand the concept of that, how it builds, how the hydrograph gets converted into this kind of a peak and then recession and first the rising. What happens when there is a rainfall event like this here at a particular time? Then all of a sudden there is not a surge in the flow in the channel. Not all of a sudden. It contributes because your catchment is large, and from the remotest area of the catchment, when water is reaching at your cross section where you are measuring the flow, takes time. So this is the time here. It is taking from this point. This is the mass curve. You know, this surface runoff takes place only when there is rainfall excess. We have seen this in phi index, that if there is a rainfall event like this, then surface runoff because of the rainfall will take place only if rainfall is in excess of the phi index. Phi index represents the total infiltration from the rainfall, and excess of the rainfall will become runoff. So this runoff is generated because of this much of rainfall, and this is a heterograph. Initially there was lesser intensity, then intensity up, and then up the 220. This is precipitation. Here you see there are two markings on the ordinate y-axis. First is the 0, 10, 20, 30, 40, 50, and then here this is different scale for this runoff, and this is for precipitation. This is for heterograph. So here, and then lower. Now this point to this point, the time takes to peak the discharge in the channel. The peak discharge we are getting somewhere here at midnight, somewhere here 0000. This is noon, 12 noon, and this is again midnight of the next day, day 2. This is midnight of day 1. So rainfall started on day 1. It lasted only this much time period, say 3-4 hours only, but the runoff took place for longer duration, 4 hours. It is covering part of day 1 and part of day 2. So you could see the runoff, which depends on many factors. Basically, we are understanding runoff and discharge into channel versus time in hydrograph. So runoff, the amount of runoff generated out of a rainfall event depends on many factors, depending upon the catchment factors as well as the climatic factors. Climatic factors, why I say? Because temperature, radiation, cloudiness, dampness, moisture level, many other factors affect the total amount coming as runoff from a given rainfall event. So before we could understand the unit hydrograph, we need to understand the hydrograph. So as soon as this rainfall event is occurring, while it is occurring, the water level in the channel where we are measuring the discharge is rising till it reaches a peak point, and from the peak it starts falling. It's obvious, and up till this, the limb where hydrograph is rising is this portion is called rising limb, and the other part of the hydrograph is called falling limb or recessing limb or recession. Okay. Now you could say that earlier the contribution of the groundwater to the channel was this much only, the 10 or less than 10 in cubic meter per second, less than 10, this much only, say it is 5 or say 4 cumax in the channel. So that much less cumax of water was flowing in the channel before the rainfall event, but it increased. You look at the dark yellow portion, dotted line is having a gradient, up gradient, till it meet the recessing limb somewhere here. Okay. Now this rise in the groundwater contribution is because of infiltration and percolation into the groundwater, which augment the contribution of groundwater into the channel. So you need to understand this. This is augmentation of groundwater into the channel. We are measuring the discharge in channel, and surface water is contributing to the channel, groundwater is contributing to the channel. Groundwater contribution has increased in 1 and 2nd day, during first day and even 2nd day. That is because of infiltration and percolation, augmentation of groundwater, and then is your called the base flow. This is base flow. This is storm flow. So clearly you could segment this hydrograph into two parts. One is the fluctuating part because of the rainfall event. Second is the lesser fluctuating part because of the groundwater contribution. So when we draw a unit hydrograph, this is total hydrograph. This is not unit hydrograph. When do the calculation, when we do the characterization of the watershed or a catchment, then we deal with unit hydrograph, not with the hydrograph. Hydrograph could be of a conduit, could be of an open channel or anything. But when we draw, we deduce the unit hydrograph. That unit hydrograph is always characterizing the catchment, characterizing the watershed, or that characterizes the drainage system. Why I say the characterization, that we'll see later, because that represents and can be used further for analysis, engineering analysis. So here we are understanding only hydrograph. So hydrograph is nothing but is a plot, is a graph between discharge in Qmax, or depending upon the unit you are using, versus time. Here it is days and it may be hours also. So this is a hydrograph. There is 2-3 terminology written here. That is lag time. This is lag time. Lag time means the time surface runoff takes to peak off out of the given rainfall event. Again, rainfall event is here and it picked up at this point of time. So this time lapse between here to here is called lag time. LAG, lag time. Instantly, it is not picking up. It picked after say 6 hours or 8 hours of time period. So that is lag time. Depending upon the catchment, the size of the catchment, many other factors included. From where this distance is taken, not the midpoint of the highest peak, but it is taken from the mass point. This is CZ of excess rainfall. This point here is CZ of excess rainfall, and this is the distance up to the peak point, vertically drawn from the peak point. So that horizontal distance is lag time. I show you. This normal flow and base flow are mostly it is written base flow, and that is also called normal flow, means flow without surface runoff contribution, or flow without rainfall event in the channel. So that is normal flow here. These points are point of inflection. You read in RCC design, a point of inflection here and here, and this is the starting point of your hydrograph. This is also the ending point of your hydrograph. Here these X and Y are point of inflection. This is another sketch of the hydrograph. This is also not unit hydrograph. Another sketch to understand more detailing of the hydrograph. Again, you could see this is rainfall to draw this heterograph. There are two curves combinedly drawn here. because we need a heterograph to draw the hydrograph. Because hydrograph carries surface runoff, so we draw heterograph for the sake of drawing the hydrograph. So heterograph is just sufficing the meaning of hydrograph here. Otherwise, if you don't draw the heterograph, then it's okay. This heterograph is not part of the hydrograph, but it is leading to the hydrograph. That's why it is always it is customary to draw a heterograph with the hydrograph. Now this peak is here, which I already explained to you. This is falling limb or recession limb. This is a storm flow, this is base flow, groundwater flow, or normal flow, you could say. This is lag time, which I have already explained. This is peak precipitation here, and this is runoff in Qmax, etc. So that is what this is a different storm, day 1, day 2, day 3, day 4. So this lasted, the hydrograph lasted for 4 days, not the rainfall event. Rainfall event lasted only for few hours, 6, 7, 8 hours only. These components I have already explained. So you just could read if you could not listen to me properly what is the rising limb and recession limb or falling limb are. Peak discharge, then the lag time, then the time to peak, then the discharge. I have explained already. Now come to the unit hydrograph. This is very important to understand what the unit hydrograph is. Now look at this sketch first. This sketch is drawn between Q versus T. Q is the discharge. Here unit is written as CFS, cubic feet per second. It could be cubic meter per second, whatever you use. So you could always convert this, and this is time in hourly basis. Earlier it was in days. Depending upon the storm and the runoff, this can be taken. And now this is hydrograph. Earlier this was very sharp. Here it is broad. This curve is broad here, direct runoff, and it is not sharp at the peak. So this depends upon the watershed characteristic. There are different sizes and material out of which your watershed is made of. Depending upon that direct runoff, peak, and the shape of your this hydrograph comes out. Now this is, if you divide this chart into two parts, then this is contribution of the rainfall. Rainfall is drawn here, heterograph is drawn here. That is intensity from 0 to 1.5 and 0.51. Rainfall axis is this. This is rainfall losses are drawn dark, and this is base flow, and this is direct runoff. Now what it says, hydrograph usually consists of fairly lower portion that changes slowly throughout the year and a rapidly fluctuating component that represent the immediate response of the rainfall. This is immediate response of the rainfall, and this is slow process which changes hardly during the year, the base flow. The lower slowly changing portion is termed as base flow. The lower slowly changing portion is termed as base flow. The rapidly fluctuating component is called direct runoff. And your hydrograph is always output of the direct runoff, not the base flow. So whenever we draw a unit hydrograph, what we do, we remove this base flow component. We just remove, we segregate this into two parts. There may be kind of reason asked in the interview, or in oral examination to remove the base flow while deducing the unit hydrograph. That unit hydrograph represents the direct runoff from a storm event, while the base flow is because of the groundwater. So there is no need to consider the base flow while drawing a unit hydrograph. So get this point technically perfectly, that we remove this base flow while drawing the unit hydrograph. So this is only taken after removal. And what is unit hydrograph? Look at the amount. What is unit hydrograph? The amount of runoff resulting from 1 unit, 1 centimeter or 1 millimeter or 1 inch or 1 foot even of the rainfall excess. मतलब एक यूनिट रेनफॉल, 1 सेंटीमीटर रेनफॉल पूरे कैचमेंट में एवरेज में हुई है, तो उससे कितना रन ऑफ जनरेट होगा, वो यूनिट हाइड्रोग्राफ है। द अमाउंट ऑफ रन ऑफ, ये क्या शो करता है कि अमाउंट ऑफ रन ऑफ शो करता है कितना पानी इकट्ठा होगा यदि 1 सेंटीमीटर की बारिश यूनिफॉर्मली पूरे कैचमेंट में हुई है तो। और इसके एजम्पशंस हैं कई कि इंटेंसिटी सेम रही थी, आपका कैचमेंट है वो होमोजीनियस है, बहुत सारे उसके एजम्पशंस हैं, हम देखेंगे। लेकिन यूनिट हाइड्रोग्राफ का मीनिंग ये है केवल कि यदि 1 यूनिट रेनफॉल हुआ है तो उससे कितना रन ऑफ जनरेट होगा और उस 1 यूनिट रेनफॉल होने में कितना टाइम लगा है, दैट इज इमटेरियल। मतलब मान लो कि 1 सेंटीमीटर का रेनफॉल होने में 4 घंटे लगे हैं, तो उसकी इंटेंसिटी पॉइंट हुई पर आवर, लेकिन हमें यूनिट रेनफॉल चाहिए। तो आपको मैं नेक्स्ट पेज पे दिखाता हूं कि कैसे हम इसको दोबारा से चेक करेंगे, आपको समझाने के लिए कि कैसे यूनिट पे आते हैं। is essentially a tool to determining, this is not representing your it does not represent anything, this is an analytical tool। जैसे हमने वेरिएंस में पढ़ा था ना कि जो स्टैंडर्ड डेविएशन है, बट इट इज एनालिटिकल टूल, इट हेल्प अस इन एनालिसिस। इंटीग्रेशन भी आप करते हैं, डेरिवेशन भी आप करते हैं, बहुत सारी चीजें होती हैं जो केवल एनालिटिकल टूल हैं। थोड़ा उसको हम कोरिलेट कर सकते हैं दूसरी चीजों से, फिजिकल वर्ल्ड से, लेकिन इसको डायरेक्टली फिजिकल वर्ल्ड से कनेक्ट करना उचित नहीं है। तो इसका मतलब क्या हुआ कि ये एनालिसिस के लिए एक टूल है जो डायरेक्ट रन ऑफ से हम डिड्यूस करते हैं और इसको वापस फ्लडिंग सिचुएशन कैसी होगी उसको समझने के लिए हम बनाते हैं। तो ये इंटरमीडिएट एक स्टेप हुआ। तो is essentially a tool for determining the direct runoff response to a rainfall. Direct runoff response to rainfall. Once you know the watershed response to one storm, you can predict what is response for another will look like. मतलब दूसरा rainfall होगा तो runoff कितना होगा, कितना पानी accumulate होगा, flood होगा या नहीं होगा। तो flooding के लिए यूनिट हाइड्रोग्राफ है वो बहुत ही एक अच्छा मॉडलिंग का मेथड है कि हम इसको यूज कर सकते हैं, इस मेथड को यूज कर सकते हैं जानने के लिए कि कितना फ्लड आएगा, कितना वाटर एक्यूमुलेट होगा, कितनी जगह डूब जाएगी, कितना सबमर्जेंस हो जाएगा, कितना नुकसान हो जाएगा, ये सब हम जान सकते हैं इस थियरी से। और न्यूमेरिकल निकालेंगे तब न्यूमेरिकल से भी जानेंगे। तो ये इसके एजम्पशंस हैं जो एक बार आप जरूर you go through these points कि हमने क्या क्या assume किया है कि before coming to the point कि ये हमारा unit hydrograph है, we assume that effective rainfall is uniformly distributed, पूरे के पूरे catchment में एक ही जैसी बारिश हो रही है, यहाँ कम वहाँ ज़्यादा नहीं हो रही। effective rainfall मतलब जो rainfall runoff generate करे, जो रेनफॉल, इफेक्टिव रेनफॉल और रेनफॉल में क्या अंतर है, जो रेनफॉल रन ऑफ जनरेट करे उसी को हम इफेक्टिव कहते हैं यहाँ पे। अदरवाइज जो कम है, जो जिसका रेनफॉल की कैपेसिटी कम है, जो ड्रिजलिंग टाइप है, वो रन ऑफ जनरेट ही नहीं करता, तो वो इफेक्टिव नहीं है। तो द इफेक्टिव रेनफॉल इज यूनिफॉर्मली डिस्ट्रीब्यूटेड, द बेसिक ड्यूरेशन